Hello, guys. Good morning, good afternoon, and good evening. Welcome to Utico Engineering Services, the house plan market. If you are joining me for the first time, you are highly welcome. Thumbs up for you. Like I always say before now, this platform is dedicated to homeowners and young civil engineering students, builders that want to have insight of construction activities, practical knowledge of construction activities. If you are here for that purpose, please take your time, sit down, relax, and listen to our everyday with construction activities works. All right. So far, so good. We've gone a long way. People have been asking me some questions. How do we apply a mixed concrete to a particular section of work? How does it work? Or where can we use a concrete mix of so grade? How do we apply it at the site? So I've looked at some of their questions based on my previous video, which I titled how to determine a concrete mix of 1:2:4. If you've not watched that video, I think I'm going to pin the link down on the comment section. Feel free to click on it and you can get all the information about that particular video. But for today, basically what I want to discuss is types of concrete grades, mixed ratio, and their uses. Okay, what are the types of concrete grade that we can apply at the site? Okay, what is their mixed ratio like, and how do we use them? Where do we apply them? I think that's what we are going to be looking at basically today. So before we proceed, I want to refresh our memory back to how you can determine the mixed ratio of 1:2:4 by volume. Okay, but before we get to that place, please, if you are joining me for the first time, I want to say a big thank you to you. If you are yet to subscribe, what are you still waiting for? What are you waiting for? Please subscribe, click the like button. This is very important, and share it to others. That way you can be helping someone you might not know. All right, apart from that, you discover that everything that we do here, we do it to benefit those that need this information, not for any other purpose. What we are doing here is we try to send information out based on our practical knowledge, based on experience. We've observed over the year, most people after graduating from schools, starting up is a big challenge. Okay, but with this, if you listen to all our construction activities, you should be able to know what is a beam, you should be able to know what is a lintel. I can bet you there are many civil engineering students that came out from school and they've never seen what is a beam. They've been designing with slab. They don't even know what is a slab. That's the truth. Some people have stayed for years without knowing what is a slab. But with what we shows on our daily today activities, you'll be able to figure out, okay, so this is how the slab look like, this is what the beam, this is what is reinforcement. I think that's basically what we do here. So if you are not sharing that, please share this video. It is very important. Okay, before I go offline, let's go back to our previous work on mixed ratio of 1:2:4. Now if you watch from your screen, you discover that we have a mixed ratio of 1:2:4. This particular work has been done before now. From this work, we have issues, we have questions of how or where do we apply this mixed ratio. Now they have known how to determine it, but the question that arises from it is where do we apply it. So this brings us to our topic for today, which is the concrete grade mixed ratio and their uses. But why I brought this back is for us to have reflection or refresh our memory on how we can determine this, because it is very, very important. Even if when you know about the concrete grade and you don't know where to determine or how to use it, like I was saying, the concrete mixed ratio of 1:2:4. Okay, what does it mean? How do you determine it? If you watch from your screen, you discover that when we say we want to work on 1:2:4, we are trying to say a portion of cement, all right, will be equal to 2 portions of the sand and will be equal to another 4 portions of coarse aggregate or chippings. All right, that is the meaning of 1:2:4. But we have a challenge here. What is the challenge that we have here? Mostly cement is not measured in bags. Cement is measured in bags, not in earthpan. Okay, while the sand is measured in earthpan. The chippings to be measured in earthpan or wheelbarrow. So it is going to be very, very wrong if we say that 1 bag of cement will be the same thing with 2 wheelbarrow of sand and 4 wheelbarrow of what do they call it, and 4 wheelbarrow of coarse aggregate or your chippings. All right, it will be totally wrong. This does not represent a ratio of 1:2:4, but from the screen you are seeing it as 1 bag of cement, 2 and 4, but basically it's not the same as 1:2:4. Why? Because the volume for the cement and the sand and the granite are not equal. I don't know if you are getting me. So it becomes a challenge. What do we do in terms of that? For us to get this right, there's need now for us to find out what is the volume of cement in terms of earthpan. Okay, so from studies and analysis, discover that 1 bag of cement will contain 2 earthpan of it. Now when you have idea that okay fine, you've been able to convert your 1 bag of cement into 2 earthpan, the next thing is for you to now move ahead to combine it with sand. So if you look at the next diagram you are seeing now, you will now see that now for this your cement that you have 2 earthpan of it, okay, it's going to be working with 4 earthpan of the sand and 8 earthpan of the coarse aggregate, or better known as chippings. I think this is clear now. All right, meaning that if you are looking at it in bags and wheelbarrow now, 1 bag of cement will produce or will be equal to 1 wheelbarrow of the sand and 2 wheelbarrow of the chippings. That is the concrete mix ratio of 1:2:4. Have you gotten the difference now? But if we have not done it this way, at the site you'll be thinking 1 bag of cement is the same thing with 2 wheelbarrow and 4 of chippings, which I've just told you that is totally wrong. And if you if your mix is that way, it means you are producing a very weak concrete mix. A very weak concrete mix. So that brings us to our today discussion. The reason why I discuss about the concrete mix is so that we can have idea of where we are going to and how we can work with the areas that we're about to discuss now. All right, so like I've said before, we are going to be discussing our major construction today is about concrete grade and where to use it. Now when we talk about concrete grade, what are we talking about? In a nutshell, what we are talking about, wherever you heard about concrete grade, okay, what they are talking about is that strength of concrete, okay, that is good enough for a particular kind of job. In construction, is being classified as grades, okay. Whenever there's a mixed ratio that produces a particular kind of strength, that strength is being allocated to be the grade of that concrete mix. All right, this is where we get the word concrete grade, meaning what is the concrete grade that you can use for a particular kind of job. If you have a job, okay, that is of less importance, there's a different grade of concrete you need to use. If you have a job that is going to be you are expecting a high level of load, there's different concrete grade that you need to use. Okay, this brings me to some terms that we are going to be applying in the course of our discussion, which I want us to discuss gradually as we progress on this our discussion for today. Okay, the first thing that we are going to be looking at is the nominal mixed concrete. What do we understand by nominal mixed concrete? Okay, I think this is not an engineering class. I'll try and make it as practical as I can. Please pay attention and try to understand where I'm going to. When we use the word nominal mixed concrete, we mean those concrete jobs, okay, that are done at the site, or the concrete mix that we are not expecting, that are going to be used for simple construction jobs. Let me use the word simple construction jobs. Those concrete mix that are used for simple construction jobs. Yes, meaning the minimal concrete mix that we can use for simple construction jobs. Okay, so any mix that is outside nominal is outside concrete mix. That's the meaning. When we use the word nominal concrete mix, it means like the least concrete mix that we can use for the least kind of construction jobs. So anything outside that is out. That one you are on your own. Okay, this nominal concrete mix is not provided from is something that theoretically over time people have carried out experiments and conclude that this basic mix by volume is good for small construction jobs, and from there they give it the name nominal, meaning the minimum concrete mix that we can use for our day-to-day construction activities, those jobs that are not expected to carry too much load. For jobs that are expected to carry too much load, there are other concrete mix that you can use. You have the standard concrete mix and you have the design concrete mix. Okay, But for our discussion today, we are going just to be looking at the nominal concrete mix. I want to believe that um you are getting me, you've gotten me clear on this. So I want to be discussing about the next one, which is the comprehensive strength of concrete. What what do we understand by term comprehensive strength of concrete? Let me explain it this way. Now, the comprehensive strength of a concrete, okay, is that strength that concrete cube will develop at the age of 28 before that concrete will fail when it's subjected to axial force or to a crushing effect. The maximum strength that concrete will develop, this is how it works. Now, when you have a concrete mix of say 1:2:4, after mixing thoroughly with water, you take a portion of it, put into a cube box of say 150 by 150 by 150 millimeter cube box. All right, after that concrete set, remove it from the cube box and you put it into water for curing. Now, when you put inside water for curing, after at 28 days, you remove that concrete, all right, and you put it into a cube testing machine. Why did you put it on that machine? You want to test the strength that concrete has developed at 28 days. Now, when you put it on that machine, you start applying force. Okay, I don't have the diagram of the machine here, but if you're a student and you want to know about the cube testing machine, you can always browse it out. It's online, it's everywhere. You have idea of it. Okay, if you want to have idea of the practical one, okay, I think we still have in other places where you can still go and carry the test yourself too. But for the purpose of our discussion, you just put it on the machine and you start applying the force on the cube. Now, as the machine starts compressing the cube itself start developing a resisting force to resist that force that is coming on it. As it's developing that resisting force, on the meter you'll be seeing it reading. Okay, now that the cube will develop a particular level of resistance. After that level, it will start dropping down. So that level that cube will develop before it start dropping down, that's the comprehensive strength for that cube. As soon as it start dropping down, it has failed. Okay, you see the cube must have crushed. But before the cube crush, okay, you will see the highest strength that cube has developed. That is what we refer to as the comprehensive strength. Now, what is the importance of this comprehensive strength? It guides us, it makes us to know the resistance or the amount of load that cube can carry before it will fail. Basically, that's the idea of testing it, so that you can have idea of, okay, this mix that we have done, so this cube can carry a load of this value. So any load that you apply on that cube that is less than the resisting strength, all right, the cube will carry it. That's the meaning. But the moment you apply a load that is more than that resisting strength, the concrete will fail. From this analysis, we still apply it to a wide range of concrete. For example, our deck. Okay, that's why when you are carrying out the design, you will look at the load that's coming on the deck. Okay, because now from the design now you've already known, okay, if a load of, for example, 40 kilonewton, 40 newton per millimeter square is going to be acting on your deck, it means that you are going to be using a deck combination of reinforcement and concrete that will resist that 40 newton per millimeter square that's going to be coming on it. If you do not provide a counter force for it, the deck will fail. From our experience of comprehensive analysis, this is where we have idea of, okay, for a slab, what are people that are using it? What is the self load of the slab? What are other additional loads that is going to be acting on the slab? Okay, how do we get our mix, our design? What criteria, what kind of grade are we going to use that we produce that comprehensive and tensile strength that will resist the load that we are looking at? I don't know if I'm making point here, but this is where we get our analysis information from, and that is the idea of the testing. Then another area that I want to understand is the characteristic strength of concrete. This is strictly for engineering students and builders. Homeowners, you might not really get to understand what I'm going to say here, but for theoretical purpose, what we use is the characteristic strength. Okay, it's known as the FCU. Okay, the characteristic strength of concrete. Now, that characteristic strength of concrete is the strength that when you have the average strength of different comprehensive strengths, okay, of which 5%, okay, only 5% of it, you understand, we fail in any test analysis. All I'm trying to say here is this: if you have a comprehensive test of about 10 different cubes, okay, and you are running the test one after the other, for you to get the characteristic strength, it must be, okay, the result of almost all the average result of all the ones, okay, that will not fail. Those ones that fail, you cannot use it. So it means that in a sample of 10, if 5 of them fail the test, you cannot get your characteristic strength from that samples. But in a sample of 10, if 1 of them fail the test and 9 pass that comprehensive test, it means that that average of the 9 will give you the characteristic strength of that concrete. I don't know if I'm getting it. The characteristic strength of the concrete, as I was saying before, let me try and get it clear. Let me try and make it clear again. Now, the characteristic strength of concrete is that strength of from different samples of the concrete test, of which less than 5%, okay, less than 5% or 5% of it will fail, meaning 95% of it will pass. Okay, so when you have a sample of comprehensive test that is not up to 95% of it that pass, you cannot deduce your characteristic strength from those samples, meaning you have to repeat the concrete mix again, find out what is wrong with it, repeat it again, and run a cube test analysis. The moment you are able to get up to 95% of the cube test that pass the result, okay, and maybe only 5% of it failed, then from that 95% of it you can get the average, and that comes, you get your characteristic strength from that average. Okay, if you are not clear on this, please drop your comment in the comment section. Okay, let me know the areas that you are still facing challenges on. Let me know the areas that you don't get clear. I'm always here to discuss with you. I can discuss with you one-on-one. I can still make out videos to get some to bring out some detailed points on the issues that we are looking at. All right, so that takes me to the points of our discussion today. Concrete grade. What is concrete grade? I want to believe that by now you've known what is concrete grade, so I'm not seeing it like a strange term again to you, because we've talked about concrete mix, concrete grades from the onset of this discussion up till now. But I just want to let you have the picture of what we mean by concrete grade. Now, concrete grade, okay, is that numerical value that we get from our concrete mix during the concrete test analysis. I don't know if I make a point. The concrete grade, the numerical value that we get, the result, okay, that we get or that we achieve from our mix ratio. If you have a mix ratio of 1:3:6, okay, at 28 days, when you carry it to test the cube to test it, and that cube produce a strength of 10 Newton per millimeter square, that 10 is the grade for that particular concrete mix. All right, in the same way, if you have a mix ratio of 1:2:4 and you take that particular cube, okay, to test, and that cube produce a result of 15 Newton per millimeter square, that 15 Newton per millimeter square is the grade for that concrete mix. Are you guys getting what I'm trying to say here? So most at times these words are interchangeable. Sometimes you can be asked, use a concrete mix of 1:3:6, or sometimes you can be asked, use a concrete grade of C10. The 10 is the numerical value of the concrete mix of 1:3:10. Then the C there is this, the C there connotes the concrete mix. So when you see on your structural design details that use a concrete grade of C10, or sometimes if you see in your calculations, in your structural calculation analysis, use a concrete grade of C15, then it is simple. You only need to know that a concrete grade of C15 will produce a mixed ratio, okay, or is from a mixed ratio of 1:2:4. A concrete grade of C10, okay, is from a mixed ratio of 1:3:6. You can carry out this result analysis yourself and run the test and have idea of the grade of concrete it will produce. This grade of concrete, they are grades that we've been using for long, and it is not derived from our Nigerian code of practice, rather we've gotten it from the BS standard code of practice. Okay, the Americans have their own code. I think they are basically the same thing. The only difference is that the American, I think they use the M. They use the M to mix their to connote their own concrete mix, while the British use C for concrete. Okay, the American use M as mixed ratio, while the British use, and that's what we are using too. So I'm using that C, so that you know that if you see M, you know that it's the same thing, okay, with C. You can see most cases, you can see C15, C10, and all this. Then another thing I want to talk about is this concrete grades. Okay, we have it from grade 5 up to I think 80, but the basic ones that we'll be discussing is the nominal concrete mix or grades, the nominal ones, the ones that we use on our day for simple construction works. That's the area of our today's concentration. Okay, so the three major ones I want to be discussing about is the C10, the C15, and the C20. All right, for C25, that is a standard concrete mix, but we normally use it at the site also, but I'm not going to discuss much about that. Okay, but the major ones I want to discuss about is the nominal concrete mix. Okay, now the next thing is how or where do we apply this concrete mix on our day-to-day site activities. How is it being applied? If you watch very very well from your background, you discover that this is one of our site work, and this a German floor work that is about to kickstart. So it's not, I'm trying to get information on how or where to apply this particular work. It's something that you need to understand. The first thing I want you to get clear is that for every concrete grade, you don't just apply it because you want to apply it. The first thing you must understand is that go back to your structural details and look at what is being prescribed for you to do. For your German floor work, if the structural engineer gave you the information to use a mixed ratio of 1:2:4, please use a mixed ratio of 1:2:4. All right, if the structural engineer gave you a mixed ratio of 1:3:6, please use what is in your structural detailing for specific jobs. But the areas where you don't have this information, this is where I come in. This is where I'm providing this information for. This information is not to be used for every site activities. Please take note of what I'm saying. This information is not to be used for every site activities. This information is to be used based on structural understanding of the job you are doing. If you are not an engineer, this information is not for you. Please, for the engineers at the house, the builders, just like I said before, the first thing you need to do is consult your structural detailing. What did they ask you to do? The reason is because every design is done based on the expected load that is coming on it. For instance, this is a German floor for residential purpose. I would propose, for economic reasons, you can use grade 10 for this situation. But like I've told you guys before, it's always better you get it from your structural detailing. Secondly, because I said use grade 10, okay, does not mean that if you want to do your own work at the site, you are going to use grade 10. The reason for applying grade 10 for this particular job, okay, it's because it's for residential purpose. Okay, we are not expecting a high load on this floor. For jobs that you are not going to be expecting a high load on, and for jobs that you are not going to be connecting reinforcement to, you can always use your concrete grade 10. When I use the word grade 10, I equally mean a mixed ratio of concrete mix of 1:3:6. If you don't know how you can determine your concrete mix of 1:3 into 6, I think we discussed about how we can determine our concrete mix of 1:2:4 from the beginning of this discussion. So you can always fall back to it, study it, and apply the same thing to what you will do for any other mix ratio. All right, so as we progress, if you watch from the back of your background, discover that there is another construction activities brought to your notice. And this particular work, if you observe it very well, you discover is concrete work with reinforcement. Okay, and this is a septic tank design, concrete septic tank. It is not like our normal soakaway pit or septic tank that you use block work for. Okay, this is for a special case. So the design I gave you previously will not be ideal for this type of construction. The reason is because this is going to be experiencing higher load than the former one. So if you are faced with things like this, that means you are still going to be you're going to need another kind of concrete grade for this particular kind of construction. I have told you before now, I'm only giving you an insight of how you know where to use this concrete grade. And I specifically told you that the work we are doing today, our discussion today, is based on nominal mixed concrete mix that we are not expected too much load on them. Okay, so we are going to be applying those grades, and those grades that are nominal grades are the grade 10, the grade 15, the grade 20. Okay, for this particular kind of work, if you did not get it in your structural details, if it's not prescribed there, if that information is not your structural detail, and you are faced with this nature of challenge, what do you need to do? Okay, because you are combining this with reinforcement, okay, you can use a concrete grade of C15 or C20. All right, but for economic reasons, you can use a concrete grade of C15. C15 means a mixed ratio of 1:2:4. Okay, for a soakaway concrete work of that nature, C15 is ideal for it. But if the design is specified to use C20, please go ahead and use C20. All right, the reason why you are not going to use C10 for jobs of that nature is because the load that's going to be applying on it is going to be a little bit high compared with the load than that the concrete grade of C10 can bear or can carry. So if you use a grade of C10, you are going to that soakaway or that design will not stand. It will definitely fail with time. I want to believe that we are clear on that. So the next thing that we are looking at is the next work you are seeing now is a foundation work. Now for a foundation work, what grade will be suitable for it? Okay, still, like I've said before, check your detailing. If on your detailing you did not see information that you need for it, I always like to tell you that for a foundation work of this nature, like for the blinding, the casting of your foundation trench that does not require reinforcement, if you are working in area that does not require reinforcement, you can use C15, a mixed ratio of 1:2:4, and the grade is C15. Okay, but when you want to work on your footings, your foundation footing and starter bars, you can use the standard mix concrete, which is C25, and that C25, the ratio is 1:1:1:2. All right, while for the C20, I think the ratio is 1:1.5:3. So now that you have gotten all these ratios and the application, I think it becomes very easier for you to know how and where to apply your concrete grade. Okay, more importantly, if you are working in a site, just like I said before, the concrete grade 10, the area we apply it, if you are working on a German floor that is going to be carrying a high load, you don't use the grade 10 for it. You can go for grade 15, which is 1:2:4, or you go for grade 20. All right, go for grade 20. It depends on the load that is coming on that particular member. So if you are working at a site and you discover that you need to use a concrete grade of C20, I think by now you should be able to know where to apply this concrete grade. Okay, if you have issues also with my explanation, if you have issues or if there's areas that is not clear to you and you want me to stress on it, please always feel free to let me know. Feel free to comment on the comment section. If you have better idea that you want to share with us, still let me know. I will be glad to welcome your ideas. Okay, because every day we learn every day, we study every day, we gain one ideas or the other. So there's nobody that is too much, that knows it all. I can learn from you while you learn from me also. I really appreciate the time that you've spent with me on this platform, and I do hope that I'll be able to clarify one area or the other that might be posing challenges on you. But if you've not gotten clarity on my discussion, feel free to still drop your comment below. I think I'll be glad to address your issues one on one. And don't forget, like I said before, please, if you have not yet subscribed, please do me a favor by subscribing, because this way you will get more information from us as we upload new videos. I'm going to be working on my next video. Hopefully by next week it's going to be out. And I think the next video is going to be on I'm talking about cracks. Yes, I did work on cracks 2 weeks or 3 weeks ago. I'm going to be talking about the remaining parts of cracks on our walls in my next video. The reason why I make it in 2 parts is because I don't want it to be too lengthy. Like today video now, if you watch it, if you look very well, it's going to close for an hour. And I know most of you sometimes might get tired along the line, but the good thing is that if there's somebody that wants to gain knowledge of this nature, you always have patience to get the information that you need, because you know at the end of the day it's going to be of beneficial to you. And I do really hope that it makes sense to you guys. And please, thank you once again. I'm going to be leaving you for now. Hopefully by next week, when I come back again, we're still going to be sharing our ideas on things that we've done, things that we know, and things that you know also. Please, I would like to get your comments on this. If you watch it and you have anything to contribute, thank you. Please feel free to contribute. Thank you so much, and God bless you. Bye bye.